Now suppose a college entrance exam has a mean score of 550 and a standard deviation of 105. Suppose a class of 15 students took the exam. What is the probability the class average is between 575 and 600? Again, I'm talking about the average of the class, not what happens as an individual. So in general, what I have is x bar, the sample averages are distributed normal, with a mean of mu and a variance of sigma squared, the population variance, divided by n, the sample size. So in this case, I have scores, the average scores, be distributed normal. 550 is the mean. The variance is 105 squared over 15. And the question here is the probability that 575 is less than or equal to the average score, which is less than or equal to 600. Now I'm considering this, or I'm treating this as if the data was actually continuous, in which case the less than equals or is strictly less than, it gives you the same thing. It doesn't really matter. If I draw a sketch, what I see is 550 is the mean right down the middle. The lower bound I'm looking for is 575. The upper bound is 600. So I'm looking for the area under the curve between 575 and 600, which would give me my probability. So in TC stats, I'd enter mu is 550, sigma is 105, and n equals 15. Now if I'm using TI 8384 calculator, some other technology, I need to look closer at the variance and remember that it is sigma over the square root of n, so I may need to enter that as 105 divided by the square root of 15. Now, if it was represented originally with the variance as being 11,025 over 15, which is 105 squared over 15, then I may simply just take the square root of the whole thing in my calculator. That would work just fine. It's not an issue, TC stats. Mu is 550, sigma is 105, n is 15, and that's all you need. So when I enter that, with a lower bound of 575, an upper bound of 600, what I get is a probability of 0.1457.